Richard, thank you very much again for sharing your time with us. Earlier this morning, as you know, we have attributed to yourself the Portuguese Science Medal, but it is always our great pleasure to have you with us. And again, I thank you for your enormous contribution over the last year to the initiative Patient Innovation led by Pedro and Helena. We have been streaming the several sessions over the day, over more than 6,000 people. And I'm pleased to announce you, as you may know, Richard got his PhD from the University of Sheffield. He's a molecular biologist, and he is well known for his Nobel Prize in 1993 on gene processing mechanisms. In the last few years, Richard has been particularly active in promoting the use of genetically modified organisms, GMOs. And actually, just before you, Inês Azevedo from Stanford University has clearly shown us the way agriculture is increasingly damaging the environment, particularly when it is compared with utilities, transportation, and other causes of external damage. So she, I believe, introduced your talk in a very peculiar way and rather interesting way, but we really want to listen to you about the safe precautions all of us need to have by adopting GMOs and your understanding how environmental preservation can also be promoted with the enlarged use of safe GMOs. Again, thank you very much, and thank you very much for accepting the Portuguese Science Medal and for your contribution to patient innovation. Thank you.
Well, thank you. Well, thank you very much, first of all, for the honor of receiving the Medal of Science. I think that is really very, very nice of you, and I appreciate that very much. What I want to do today is to talk about GMOs, which is something that I think is particularly important to talk about in Europe. And the reason for that is that there is tremendous, really, people, there are many people in Europe who just do not understand the importance of GMOs because there has been so much misinformation put out about them. And I think this tends to be not just a problem with GMOs, but a problem within our society at the moment is that misinformation keeps coming all the time. I got involved in this a few years ago, and basically we have now 156 Nobel laureates who call for science honesty about GMOs. We call on the Green parties to stop scaring everybody about GMOs by pretending they're dangerous or must be banned, because frankly, there is just no evidence for this whatsoever. Not a single case of a problem over 30 years. And you in Europe, in particular, import billions of tons of GMO foods to feed your animals on the farms. If there were a problem with them, we would have seen it by now. Have you heard of a problem? No, and nor have I. Now, food means agriculture. And for 10 to 12,000 years, we had been using crude genetics in order to improve plants that we grow to eat. But in the 1980s, we learned something very new. We learned how to be precise. And we learned about it thanks to work that was done by Mark van Montague in Belgium and Jeff Schul in Belgium, and by other people around the world, including Mary Del Chilton, who was in the USA. And basically, what they learned was how to make crops better. Now, if we look at the evolution, the way in which a typical crop that we eat today, corn, if you look at the top right, you'll see what a typical piece of corn that you buy in the supermarket looks like. So a nice corn cob, looks delicious, tastes delicious. But the wild ancestor of that corn cob looked very, very different, and it's shown on the left. This is teosinte, which was grown in Central America, a very thin plant, very thin cob, almost no kernels on it. And slowly, the people in Central America figured out how to domesticate it, how to get better varieties, and slowly improved it until we get to the corn that we find in the supermarkets today. Now, this was not done by completely natural means, it was done by plant breeding. And what it means is the DNA that is in the corn that we buy today is different from the DNA that was in teosinte. There's been much modification, much selection for better varieties. If we compare conventional breeding, which led to sweet corn, as opposed to precision breeding, I have a diagram here which gives you a good idea of what we're talking about. On the left, conventional breeding means that we take a plant we're already growing and perhaps are eating already, and we want to improve it. We want to add a gene that maybe will make it grow taller, maybe it will make it taste better, but we'll do something to improve it. And so we take a plant that has that gene in it, and we take the elite variety, the variety we're eating at the moment, and we make a cross in much the same way that one makes a baby when two people decide they're going to have one, so that the genes from the mother and father get mixed, as they do here. And when we look at the first hybrid, the one shown in the middle of the left-hand diagram, this has 50% of the genes from the elite variety, 50% from the related variety. Now, we don't want all of the genes from the related variety. All we really want is that blue gene. And so what we do is we do another cross. We take that first hybrid, cross it back to the elite variety, and keep doing that until we've got mainly the genes from the starting variety, and we have the blue gene still maintained. We check all of the hybrids we produce to see if they're okay. And if we can't get what we want that way, then we use mutagenesis. We irradiate the plants. We treat them with chemicals to make mutations and hope that we can get what we want that way. That is traditional breeding. And that's considered safe by Greenpeace and by the other anti-GMO organizations. But on the right-hand side is precision breeding. It is the GMO approach to making new plants. This was discovered by Mark van Montague and Jeff Schell, and they found that there is a natural process, completely natural process, in which a bacterium called agrobacterium transfers genes into plants that it grows on. And it does it because on its DNA, on a small DNA, a piece of DNA, a plasmid present in the bacterium, you can take that plasmid, an agrobacterium will move the genes, will move certain genes into the plant. And what Mark discovered was that, well, all you need to do is to put the gene you want into the plasmid rather than the one that the agrobacterium wants. And in this way, you can get the gene you want into the plant. And you can do it in a very precise way that is totally different from conventional breeding. And yet what you end up with is a product that is probably much cleaner, much safer than the one that you made conventionally. Greenpeace argue this is dangerous. And why do they do that? Well, we'll talk a little bit about that in a moment. But in case you didn't understand all of this, let me give you a nice indication, a sort of an easier way to understand the difference between precision breeding and between the old methods. I've got a GPS system in my old car, and I've just bought a new car. And I want to take that GPS system and put it in my new car. So do I disassemble the two cars? Do I take them apart and mix everything up and then select for the one that has picked the GPS, ignoring whatever else it might pick up? Well, no, of course not. What we do is we take the GPS system from one car and simply move it into the other. That is the precision method of making so-called GMO plants, genetically engineered plants. And if you listen to Greenpeace and the anti-GMO people, they will tell you, well, what if instead of taking the GPS from a car, what if I take it from an airplane? Does that mean that the new car is now going to fly because it got the GPS system from the airplane? Well, of course not. It takes a lot more in order to make it fly. And yet again, the anti-GMO people will tell you if I take a gene from a salmon and put it into a plant, there are going to be all sorts of deleterious consequences. As though the fact that this piece of DNA that came from one organism and was put into a plant is all of a sudden going to bring with it all of the attributes of the organism it came from. It's patently false, it's not true, but it's easy to scare people. And this is really the problem, is that the anti-GMO people have become very good at scaring people. And what you have to realize is that what's important is the product, not the method. It doesn't matter how you make the product, it's the actual product. Is it safe or is it not safe? And this is just as true for traditional breeding as it is for the GMO technique. It's as though you go into a store, you look at a nice dress, and you say, well, I like that dress, but how was it made? Well, if all you worry about is how it was made, you probably would not buy the dress. You want to just look at the dress and decide, is the product good? Is it bad? Is it nice? Do I look better in it? This is what's important, is the product. Now, in the USA and Europe, big agricultural companies have invested very heavily in traditional breeding to improve crops, so that most of the staple crops that we consume have been produced by breeding, traditional breeding, even though it's extremely slow, it takes a long time to do it, and it's not that precise. Nevertheless, there's been huge investments. And why? Because people have to eat. And so if you can make food a little cheaper, it doesn't cost you as much to get it there, then that's very good. People have invested in that. But there's been no such effort in the developing countries. And why? Because you can't generate the profits in developing countries. They don't have the money to buy all the food and to pay for all of the breeding that is needed to improve the crops that they eat. But the nice thing is that these new methods, the precision breeding, GMO method, can help, because you can do in a very short period of time what takes tens of years very often to do by traditional breeding. So we might ask, why does Europe claim this is dangerous and try to block it? What is the purpose of this? Why would they do this? Do they not care about the developing countries? Well, the bottom line was that the Europeans didn't want US agro-businesses, the big companies in the US, to control their food. And so how can that be prevented? Ban Monsanto and other big US agri-businesses. Oh, but you can't do that, because it turns out the seeds that you grow come from Monsanto and the other US agri-businesses. So how can you strike a blow at these big US agri-businesses other than by just banning them? Well, the answer was, we can pretend that the GMO method, the precision breeding, might be dangerous. Perhaps it is dangerous. And of course, as soon as you start to imagine something can be dangerous, it's easy to build stories to show how dangerous it might be. I'm sure all of you have seen the Hollywood movies, Frankenstein, and so on. It's very easy to scare people. And the problem is, once people get scared, it's very difficult to reassure them. They don't take to that very easily. And so the politicians and the Green parties, they're going to protect you from this risk, this fantasy risk, by banning growing GMOs. And the beauty of that is it had no economic consequence whatsoever for Europe. Okay, Europe is not short of food. How many thin Europeans do you see walk in the streets because they don't have enough to eat? Very, very few. And so doing this approach, by focusing on GMOs and banning them, they could strike a blow at Monsanto and the big agri-businesses, without any local economic consequences. But there have been economic consequences because this movement by the Green parties has been their best fundraising effort ever. Now, when I say that, I would argue that as soon as you start to get people scared about something and you then use this as your policy platform in order to raise money, you have to be very careful not to destroy your basic mission. Greenpeace does a lot of good things. They've done very many good things. But this, which became such a good fundraising effort for them, is not a good thing. It is something they should not have done. They always claim, they worry about the science, they look at the science. The science says these things are safe. Experiment says these things are safe, and yet they continue. And I think it's because of the fundraising, because it has been such a good fundraising mechanism for them. And of course, not content with blocking precision agriculture in Europe, you can't say, well, these plants, these GMO plants, they're really dangerous in Europe, but they're okay in the developing world. The developing world needs them, we don't, but nevertheless, they can't be good for the developing world either. And so what they've gone and done is like missionaries. They've gone out and scared the politicians in the developing countries that really need GMOs. And now in many developing countries, they won't use them. They won't commercialize them. You can't get your hands on them. Now, I want to give you some idea of things that can be done and things that are in process of being done. And one of the things that I like to use for this is vitamin A deficiency. Now, vitamin A deficiency is a major problem in countries that don't have adequate supplies of nutritional food. Something of the order of 2 million people die every year because they don't get enough vitamin A. Compare this with HIV/AIDS, with tuberculosis, with malaria. This is a major problem. Now, in 1984, a scientist called Peter Jennings had the idea that maybe we could do something about this. Maybe it would be possible to find a new source of vitamin A, and in particular, a source that everybody ate in the developing world, that, well, most people did, that didn't at the moment have vitamin A in it. Now, vitamin A is made from something called beta carotene. It's the orange pigment that you find in carrots, that you find in a number of plants that have an orange color associated with them. And so in developed world, we typically get all the vitamin A we need purely by consuming regular foods that we eat all the time. So Peter Jennings said, why don't we convert rice and enable rice to make beta carotene and then to provide vitamin A? This was brought to fruition by Ingo Petraikas at the ETH in Zurich and by Peter Bayer at the University of Freiburg. This became a reality in 1999. That's 21 years ago. Normally, when you have an improved plant of this sort, within 2 to 5 years, this is getting out into the fields, improvements are being made, and then commercial production is undertaken. But it's a GMO, and only now will it soon be available. We hope next year it will become available. And there have been multiple years of delay because of regulation and opposition because it's a GMO. And I think you can easily understand why this became such a target for the anti-GMO activists. Remember all the diabetics who take insulin? They take human insulin to solve their diabetes. Where do you think they get that from? Where does the insulin, human insulin, where does it come from? Does it come from humans? No, it comes from a GMO organism. It comes from a yeast that has been engineered in order to make human insulin. Do you hear the anti-GMO people protesting about that? I've not heard anything. However, they saw with golden rice that here was something that could be likened to a pharmaceutical because it was going to solve a medical problem. And they saw this as a target. If they allowed this to get out onto the market, who knows what is going to follow? And so they worked particularly hard to try and stop it. Now, I want to also talk about a few other things. Bananas. Bananas are really a major source of calories in a number of countries in Africa. In particular, in Uganda, about 30% of all of the calorie that are taken up by the population come from bananas. Now, there's a problem with bananas. First of all, they're very difficult to deal with. They're not easy to manipulate genetically, very difficult even with traditional methods to make changes. But in fact, it turns out with GMOs, it's relatively straightforward to do so. But bananas were suffering, they suffer from many diseases, but one was Xanthomonas wilt. This is a bacterium that destroys the bananas and makes them, well, you can see in the picture on the right-hand side, this just doesn't look like a healthy banana plant. Now, there are many varieties of bananas, some more than 400, that are held in a seed bank in Europe. In this bank, all of those were tested to see if any were resistant to Xanthomonas wilt, so you might transfer the trait into the commercial bananas. But none were found to be resistant. Every single banana in that collection was sensitive. But sweet pepper, which is widely eaten in Africa, is resistant to Xanthomonas campestris, and there are two genes that mediate the resistance. Using precision techniques, you can take these two genes, just these two genes, put them into banana, and now the banana is resistant to Xanthomonas wilt. Sounds like a wonderful solution to me. Sounded very good to the Ugandan farmers, the banana farmers who saw this in action, but they're GMOs. And so there has been constant problems, constant attacks. Eventually, the parliament in Uganda came up with some guidelines as to how this might be commercialized. They sent it to the president of Uganda, and he normally would just sign the bill and away it would go. And he actually is in favor of GMOs. But it turned out that his wife and daughter were anti-GMO because they'd been gotten to by activists. And they persuaded him to demand changes in this bill, which would have made it impossible to grow these bananas in Uganda. We do know that there is some evidence that farmers are growing them anyway on a small scale. Another big threat to agriculture in Africa is the fall armyworm. This was something that caused major problems in the US, in the south of the US. It was eating all the corn. Scientists in the US came up with a solution, agricultural scientists, and they put a gene called BT gene. It's a toxin that really allows plants that have the gene inserted into them to be resistant to a number of insects, but including the fall armyworm. This saved the cotton plants in the southern part of the US. They've been growing them this way for years, and it's great. In South Africa, they had a problem with fall armyworm. They took the plant, the corn, from the southern part of the US and started growing it in South Africa. It grows perfectly well. But in Zimbabwe, Zambia, Namibia, Malawi, they have governments that were totally opposed to GMOs because of the anti-GMO activists. And in Zimbabwe, Mugabe was particularly against it. Now he's gone, fortunately, and I spoke not too long ago with the Minister of Agriculture in Zimbabwe, and they are looking to start growing these BT crops in Zimbabwe so they can feed their population. Is that such a difficult thing to do? Been dealing with this in the US for many years. In South Africa, they do it. It works perfectly well. Why would Zimbabwe and Zambia and Namibia and Malawi not also follow suit? In Bangladesh, this same BT gene was put into eggplants because the eggplants were having a major problem with insects eating them. And now in Bangladesh, this has been so successful that they actually grow more eggplants than they can eat. In neighboring India, in Assam province, it is illegal. Nothing with a GM in it can grow in India with the exception of BT cotton. BT eggplants, no. And so what are the farmers in Assam doing? They're going over the border into Bangladesh, finding some eggplant seeds, and they're growing the BT eggplant there, and just don't tell the government about it. And I think for many situations, this is what's going to happen. This is going to be the saving grace for the whole GM revolution, is that the farmers want it. They know what works and what doesn't work. They have families to feed. They have communities to feed. They're not going to let anti-GMO activists take over their whole show. Very interesting case in the US. So this was in Hawaii. They had a big problem with the papayas. This was many years ago now. The papayas were very sensitive to something called ring spot virus that was carried by insects. Scientist called Dennis Gonzalez at the University of Hawaii said, I think I can perhaps stop this. And so he engineered papaya trees so that they were in fact resistant to ring spot virus. Essentially what he did, the transgenic papaya plant, he called it rainbow papaya, has in it essentially an immune system that has been introduced genetically. Now, more than 70% of the crop grown in Hawaii is genetically engineered and has been eaten in the US for many, many, many years, in Hawaii and throughout the US. What happened was that a few years ago, the anti-GMO activists wanted to introduce labeling laws so that anything that was GMO had to have a label on it saying GMO. When the Hawaiian farmers heard about this, the papaya farmers, they said, you can't do this. It's going to cripple us. We're not going to be able to sustain our agriculture. Hearings were held in the courts there. And so what happened? What did the politicians do? Well, they listened to the farmers and they said, look, we're going to introduce this GMO labeling bill. Everything's going to have a GMO label on it, but we're going to exclude papayas because they were done so long ago, it's as though they're not. We're just going to ignore it. And so they made an exception so that the papayas, the rainbow papayas, could be excluded. Now, here are people around the US eating these papayas perfectly happily, no problems. In Thailand, they have the same problem with ring spot virus. And there, the solution is banned. So what are the farmers doing? They're going to a neighboring country that in fact has transgenic papayas that are resistant to ring spot virus, and they're just importing them into Thailand and growing them anyway. For developed countries, food is not a problem, but we must never forget the consequences of our actions for the developing countries. If we say something is dangerous locally in Europe, you can't then say, well, it's perfectly safe for the rest of you. You're going to have to say it's dangerous too. And if you're doing something purely for political reasons, which is what happened for GMOs, all the anti-GMO politicians, you've got to remember, you cannot pretend that something is safe here, dangerous elsewhere, or vice versa. And we need to get a lot more science in politics and less politics in science. And I think this is also equally true for the current COVID situation, which in the US, where I live, is now totally out of hand. Now, if you don't want to eat foods that have been derived by GMO techniques, then don't. It's your choice. But don't pretend you're doing it because foods are dangerous. GMO foods are not dangerous. If anything, they're probably safer than traditional foods. And I say, have a heart. Non-GMO is a Western indulgence of the rich, but it doesn't work for the poor in Africa, who don't ask, what will I eat today? They ask, will I eat today? And I think this is a lesson that we could all bear in mind when we see a nice table like that in a French restaurant. Let's remember that if we're going to be anti-GMO, it is the children on the right that are going to be affected by your anti-GMO moves. And I would like to just give a recommendation for this movie called Food Evolution, which deals with this. It's a little documentary. It's pretty good, narrated by Neil deGrasse Tyson. Very good movie that shows you what the GMO and the anti-GMO revolution is about. And the book on the right is a history of golden rice that came out recently from Ed Regis, in which it's clear that the anti-GMO activists have had a major problem on something that really should be widely available in the developed world. And at the bottom is the Nobel laureate's website, supportprecisionagriculture.org. On there, you can see the names of all of the Nobel laureates who've signed on to this campaign, all of whom support this idea that GMOs are perfectly safe. And there is the opportunity for you to sign on too. And there is a large amount of ancillary information, other information about GMOs and the GMO revolution. And with that, I will stop. I'll thank you for your attention.